All right, welcome to page 71. For this question, or for this worksheet, we're going to add two pieces of information to the top here. The first thing I would like us to add is prime numbers. Our prime numbers, so first, there are 10 cards numbered from 1 to 10. So we're only going up to 10 for our set. All right, so our prime numbers within our number range from 1 to 10 are as follows. We have 2, 3, 5, and 7. Actually, that's the only thing that I want to add for the top here. For my workspace down here, I'm going to create my set of numbers of 1 to 10. All right, let's look at this question. 3 cards are drawn without replacement. If keyword without replacement. If the numbers on the first and second cards show 4 and 6, find the probability of selecting an even number on the third draw. Let's set up our equation. Let's find our total. We have 1, 2, 3, 4, 5, 6, 7, 8. Now let's find our desired. Selecting an even number on the third draw. An even number. We have a desired number of 3. So that 3 is going here. All right, good job. Let's move on to question number 2. If the conditions are the same as in question 1, find the probability of selecting an odd number on the third draw. So let's set up our workspace exactly like we did before. We're going to cross off our first draw and our second draw. Which gives us a total of 8. And now we investigate. Find the probability of selecting an odd number on this attempt. Let's circle all of the odd numbers. All right, let's count them up. We have a total of 5 over 8. All right, question number 3. If two cards are drawn with replacement, find the probability of choosing a prime on both the first and the second draw. On the first and the second. Do you remember what symbol I'm going to put here in the middle if I'm dealing with the words and the second draw? We are going to be putting a multiplication sign just like that. Let's set up my first equation here and set up my second equation there. If two cards are drawn with replacement, so they are going to be the same, we are resetting our decks. Our totals are being reset. So that's a keyword. Find the probability of choosing a prime number on both the first and the second. So what is our total? How many numbers do we have to choose from? We have 10 to choose from. Now here's the thing, we are replacing the cards, so the total on the second one is also 10. Find the probability of choosing a prime number on both the first and the second. So we are looking for a prime number on the top. How many numbers do we have to choose from that are prime numbers? We have 4 numbers to choose from that are prime. So our 4 goes here. And we've replaced the cards, so there's no change. 4 also goes over here. Now we multiply our fractions. Let's multiply the tops of the fraction. 4 times 4 will give you 16. 10 times 10 will give you 100. All right, let's move on to the last question here. Excuse me. If two cards are drawn without replacement, find the probability of drawing a 4 or 5 on the first draw and any prime number, and any even prime number on the second draw. All right. And all right, let's go first, second. If two cards are drawn without replacement, so we are not putting them back, and we're going to have a multiplication. Find the probability of drawing a 4 or a 5 on the first draw. A 4 or a 5. How many options do we have? 2 options. What's our total? We have a total of 10 numbers. So we have a possibility or a probability of choosing a 4 or 5, 2 out of 10 on the first draw. But let's say and in combination with any even prime number. So here's what we have to understand. We've taken one away. So our new total is 9. And let's find out how many even prime numbers there are. Out of these prime numbers, how many of them are even? There's only one even prime number. And so since there's only one option, we put it on the top spot. Let's go 2 times 1, which is 2. 10 times 9 is 90. All right, good job. I'll see you over on page 72.